Alright guys, welcome back to the video notes for honors geometry. Today we're getting into our next section, or our next unit, which is going to be transformations. So before we get into this, or before we start taking the notes, I do want you to label a new page in your notebook so you can go ahead and find a clean sheet of paper. And at the top, just need you to write Unit 4. And like I said, what we're talking about with this unit is transformations. Transformations here. And here's some good news to kind of give you guys for this unit. First thing is it's going to go pretty quick. We're really going to only do this for about a week and a half, trying to just get up to pretty much Thanksgiving. And then we'll start our last unit of the semester after that. We're not going to have a test for this unit. We'll pretty much just have a quiz. And then the last good thing about this unit is we don't have any proofs with this. We're just kind of talking about the basic ideas with some different transformations that we can do with shapes. Okay, so with all that being said, you can label your notes for today. This is 4.1, and we just call this the basic transformations. Date today is the 13th, if you'd like to add that. And the objective is we want to be able to define the basic transformations and then use these different rules to show where they would end up, or in other words, what the new coordinates would be. All right, so we'll take this one pretty much step by step, or transformation by transformation. So first one here that we're going to talk about is called reflection. So hopefully you've heard this word before, but a reflection in terms of geometry is when we flip an image when we flip an image over an axis. I'm going to move myself here possibly. When we flip an image over an axis to create a new image. Okay, and we can do this over lines as well, but essentially what we're doing is we're taking some image, so it could be a shape, a triangle, a square, a circle, whatever, and I'm flipping it, or mirror imaging, taking a mirror image of it and flipping that over an axis. So in general, usually what we'd be able to do is we'd be able to kind of show this on an activity that we do, where I'd have you guys get on laptops and kind of explore this a little bit, but unfortunately we don't really have the time for this unit to do that, so I can just show you guys this real quick. If I'm looking at this here, this would be an example where I have some image. So most of these images that we talk about that you'll see on the different problems that you're working on are usually triangles. So I'm going to take this triangle, and let's say we want to reflect it over an axis. So I'm going to use the tools here on this website. I'm going to reflect it over a line, and reflect this over the y-axis. And when I do that, it should pop out a mirror image of whatever we just saw. So notice it just goes right over the y-axis. Okay, this is what we call reflection. Okay, if we want to think about a word to kind of go along with this, we would just call this, or that word would be flip, or mirror is the idea. Okay, so this is the first piece. And if I really wanted to, on these problems, my questions are always going to be, here's your first image, where does this image end up? And what you could do is you could just kind of draw this out by hand and say, all right, this is where it would end up if I just go, two spaces over from one side to the other. The problem with that is sometimes we want to do this a little bit quicker and try to be more efficient. And the real goal that we're trying to get to is if I just gave you the coordinates, so if I didn't even give you the picture, but if I just gave you the coordinates for a shape, would you be able to tell me where that shape would end up without having to graph it out, without having to grab graph paper and draw it and everything like that? And so this is where we come up with these rules for each of our transformations. And the rules have to do with how the coordinates are going to change. So I'm going to move myself over here. All right. So the rules. So if we are reflecting over the y-axis, I want you to write this down with me. If we're reflecting over the y-axis, we're thinking about how the coordinates would change. Remember, it's an xy coordinate. So xy coordinate. What will happen if we reflect over the y-axis is the x coordinates flip their sign. So again, if we're thinking of that word flip, same idea. The x coordinates flip their sign. So if it's positive, it becomes negative, and vice versa. And then the y coordinates stay the same. The y coordinates stay the same. Okay, that would be our rule here, and I'll show you an example to kind of practice that a little bit, but that is our rule. X coordinates change their signs, Y coordinates stay the same. All right, next one here. Let's say I change it. So instead of reflecting over the y-axis, so going like this, I want to reflect over the x-axis. So going, down and up, or up and down over the x-axis. If that was the case, the rule is this. We do the opposite. We say the x-coordinates stay the same. The y-coordinates flip their sign. Okay, very important that you're writing this down with me, because this is the huge piece of this unit. It's just being able to say, what is my rule when I reflect? Let me go back and check. All right, that's what I do to the coordinates. All right, and then the last one we have here, if we have the line y equals x, so that's a line going from the bottom left to the top right, or for you guys it would look like this, bottom left to top right. And what you would do if you reflect over that line is we're going to say this. We're going to say the rule is the x and y coordinates switch places. The x and y coordinates switch places. So they're not changing their signs. They're still saying the same number, except, if I had the coordinate 1, 3, if I reflected over that line y equals x, then I would just switch it and say 3, 1. Okay, that's the basic idea here. All right, so using that, looking at an example here, let's say I was given this trapezoid ABCD. I want to reflect it over the x-axis, and then I'll give the coordinates of the new image. For this first one here, I do want you to pause your video and sketch this. You just need to draw the x-axis and the y-axis, so just a little 5 by 5, and then just draw in roughly where those points are at. And then we'll label them together and then say where they're going to end up. Okay, but I do want you to do that first. So pause your video and do that. Okay, and I'll move myself down here. Okay, so if we have this trapezoid and I want to find where the shape ends up, first thing I'm going to do, I'll take all these apostrophes off, is I want to write where my coordinates are to start. That's a huge piece of it, because if I don't get the correct coordinate from where it begins, then no matter what, my new coordinate's going to be incorrect. So if I look at this here, making sure we understand how to plot points, A is at the point 2, 1. So remember, we go x coordinate first, so left and right first, and then up and down. B is at the point here, if I move myself, 5, 2. So I'm just going to write these down. I want you writing these down with me, A and B. C is at the point 4, 5. And then D is at the point 0, 5. All right, so I need to make sure I have all those down. And then once I do that, like I said before, in general, you could draw this out and show, see what it would look like if I reflected over the x-axis, but it's easier just to use my rules, or it's quicker just to use my rules here. So I'm going to draw these arrows here, and when I have an original image, these are all my points, and then when I have a new image, what we do is we add this little apostrophe to it, and what we call prime. So A goes to A prime, and B prime, and C prime, and D prime. Okay, it has no relation to prime numbers, but that's just what we call it when we have a new image. So if I want to reflect over the x-axis, I'm going to go back to my rules. I'm going to see what was the rule for the x-axis. Well, it says the x-coordinates stay the same and the y-coordinates flip their sign. So I'm going to do that first piece here. On the x-coordinate, that's going to stay the same, so it stays +2. And then the y-coordinate, we said it changes its sign, so it changes from +1 to -1. And that would be my new coordinate. And if we actually plotted these out, we could see and check our work and make sure these are correct. And on your homework, you will be doing that. Now for B, same thing. X-coordinate stays the same. Y-coordinate changes its sign. So it goes from +2 to -2. And I continue to do this for the rest of the coordinates. So right here, 4, 5, 4 stays the same. 5 changes the sign. And then same thing with D prime here. 0 stays the same. 5 becomes -5. Okay, and like I said, you can kind of see how this would go a little bit faster. This is a little bit more efficient than if you were just trying to draw this out by hand. So keep that in mind when you're using these rules. It's a lot quicker just to use them rather than having to draw it all out. All right, so that is reflection. That's some of the rules that we can use. Another transformation that we're going to talk about today, we're going to talk about 3 total, is what we call translation. Okay, so I'll have you guys write this definition down with me here. I'll scroll down. Okay, translation says this. It says when we move an image from one location. Okay, when we move an image from one location, it creates a new image. And like I said, these images could be an actual image or a picture, but in general, in geometry, usually we just see them as different shapes. So I could just move a triangle or a circle or a square, or, pentagon, whatever. So, like I said, if we wanted to visualize this, usually what we could do is use a computer program, but I'll show you this here. So let me just erase what we just did. And let's go for translation now. So I'm going to draw the vector that it would go here. And let's see, I think we need to draw a vector real quick. So let's say I want the triangle to go over 3 coordinates and then down 2 coordinates there. So I'm going to draw this vector. And then what we do is we say we translate on this vector here. So I take my original shape and I translate it using this vector. And notice when I do the translation, it's just moving it. So notice the orientation of the triangle doesn't change. It's still facing the same direction. It looks the exact same. All it's doing is it's just moving. It's just kind of shifting. So if you want to think of a word for translation that goes along with this, you could think of move or shift. It doesn't turn, it doesn't spin, it doesn't flip or anything like that. It just moves. Okay? And so the good news with that is that means our rule for, let me get the notes pulled back up here. The rule for translations is pretty straightforward. Okay, so I want you to write this rule down with me here. This is going to be translating over a vector. And I'll have you write this beneath as well. In general, you're going to get a vector. You're going to get some way that it needs to change. And it'll look like this. It'll have these little kind of caret symbols, or I guess sideways caret symbols. And it'll have some number here. And we'll write, actually I'm going to write it out here. Caret symbol, x, comma, y. So the x and y are just representing some number that's going to be in those spots. There'll be a number at the beginning and then a number at the end. So all this is telling me here is whatever's the first number tells me how to change the x coordinates. Okay, whatever the first number is, that tells me what to do to all the x coordinates. And then whatever the second number is, you can kind of guess, is that's how to change the y coordinates. Okay, whatever is number first is going to tell me how to change the x coordinates. So for example, if it's, and this is just going to be addition and subtraction. So if I see positive 4 as my first number, that means I just add 4 to all the x coordinates. If I see negative 2 as my second number, that means I subtract 2, since it's a negative, from all my y coordinates. Okay, simple as that. That's all I use for my rules for translating. Okay, so again, we have an example here. I'll move this right here. Whoops. I'll move myself up a bit. And here's what I want you to do is I want you to take a sec. I want you to do the same thing. And you can kind of, honestly, you could just add this to the one that you just already drew. But I do want you to draw this shape. Again, just draw the x and y axis and plot where this triangle is at. And then we'll come back together here. Okay, so hopefully we have this written down here. We have this roughly where it's plotted. It doesn't need to be exact. And what we're told is, given this triangle, we want to use the vector 4, negative 2 to show where it would end up. So first thing, just like the last one, is I always need to make sure I have my coordinates correct at the beginning. So we're going to start with E here. So notice E is at the point negative 2, comma 1. F is at the point negative 1, comma 4. And then G is at the point negative 6, comma 2. Okay, so we have this triangle and we have the points where it's at as of right now. What I want to do if I'm translating, same thing, if I wanted to, I could just move this over. So the positive 4 would tell me to move it 4 to the right, and the negative 2 would tell me to move it down 2. But in general, I can just use my rules. And remember, when we change the image, it goes from E to E prime, F to F prime, and then G to G prime here. And if I'm using this vector, like we said, if I'm confused, I can always go back up to my rule. It just says how to change the x coordinates or what to add to the x coordinates, and then how to change the y coordinates here. So if I have a positive 4, that tells me I need to add 4 to all the x coordinates here. The first number is positive 4. So that tells me if e is -2, the x-coordinate is -2. When I add 4 to that, that now becomes +2. And then the second number tells me what to do to the y-coordinates. So since it's -2, that tells me to subtract 2. So my original y-coordinate on E is 1. When I subtract 2 from that, now it becomes -1. And we're going to do that same thing with the rest of these points here. So at F, the x-coordinate is -1. It tells me to add 4 to that. So -1 plus 4 gives me a +3. And then 4 is the y-coordinate, and it tells me subtract 2. So if I subtract 2 from that, and now it just becomes +2. And same thing with G prime. -6 plus 4 is going to give me -2. And then +2 minus 2 is just going to give me 0. And these would be my final answers here. When I'm grading the homework, you will have to draw out where the image ends up. More specifically, I'm going to be more focused on the coordinates and seeing if they are correct. Did you use the rule correctly? So make sure you're using these rules. Make sure you're double checking your work and seeing, did I add everything correctly or move everything around like I should? Okay? All right. So that's number 2. Last one here that we need to introduce as well. Talked about reflection, talked about translation, and now the last one here is rotation. Hopefully this is another word that you've seen constantly used in everyday life. Okay? But rotation here, what it does or what it says is it's when we, okay, I'll give you a sec to write that. Rotation, when we turn or spin an image a certain degree and direction. Okay, I'll give you a sec to write all that. Rotation is when we turn or spin an image a certain degree and a certain direction to get a new image. Okay, we get a new image when we take whatever shape, whatever image we have, and we turn it or we spin it. And usually we're doing that around the origin, so around the center of the graph. We're not changing it just where it's at. It is going to move to a certain spot. So for an example, to visualize this a little bit, if I get the program pulled back up here, let's undo our translation. Let's say we have our original triangle again. I'm going to need to put a point at the origin because, like I said, all of these are going to be rotating around the origin, or in other words, 0, 0, right around here. Okay? So when I have this, if I use this rotate tool that this has, I'm going to take the point, or I'm sorry, the triangle, I'm going to rotate it around my point, and then in this case, or in this program, it asks me how much do I want to rotate it? And remember, that's the degree part. So I said the direction, which we'll see in here in just a second, and then the degree as well. And usually what we'll rotate around with degree is we'll either say 90, 180, or 270. So to keep it simple, let's say 90 here, and then we have the choice of either going counterclockwise or clockwise. In this case, we're going to go counterclockwise just so we can see where it ends up. So when I hit OK, it'll rotate this around, and notice our triangle has now spun or turned. So it's not a mirror image of itself, but we started in the top right box, and then we rotated 90 degrees counterclockwise and ended up in the top left quadrant. And this is what it would look like. So we could kind of investigate and see how this is going to change our points and try to do this by hand. But like I said, that's why we have these rules to help us see where those points are going to end up if we are not trying to use a computer program to do this. So like I said, we have 3 different ways of rotating. And here's what I'm going to say for this. For rotating 90 degrees, the rule is this. Okay, the first thing you need to do is the x and y coordinates switch places. So kind of like we saw with reflecting over y equals x, I'm going to switch the places of the coordinates. That's the first thing I need to do. There's also one other thing, but the x and y coordinates switch. Then, next thing that needs to happen is I need to change the sign on one of the coordinates. And this is going to vary depending on the direction that you go. So I'm going to say, and then change the sign on one of the coordinates or flip the sign, and then change the sign on one of the coordinates depending on the direction. Depending on the direction. Okay, this is the toughest rule that we have because it's not necessarily one set thing where it's I'm always going to change the X or I'm always going to change the Y, because that can change depending on the direction that you're going and how long you're rotating. So what I say instead is I want you to try to visualize that, and we'll see what that looks like in this example that we do at the end here. But that's rotating 90 degrees. Okay, rotating 180, this one's a little bit simpler. Rotating 180, all we do is this, is we say the X and Y coordinates both flip their sign. Okay, they both flip their sign. If I go 180 degrees around the origin, it's basically like going half of a circle, because remember a full circle is 360. So if I go half of that way, the points are going to end up in the same spot. If they, if you start in the bottom left and you end up in the top right, the only difference is the coordinates are going to have different signs. So you just change, if they're both positive, you change them to negative, and vice versa. Okay, so that's the only thing that you need to do for rotating 180. And then rotating 270. Okay, notice if I was rotating, if I thought of a coordinate plane here, let's say I had a point right up here. If I rotate 90 degrees counterclockwise, I would go over here, kind of like we talked about or we saw in that example. Now if I did 270, but if I go the other direction, I'm still going to end up in the same spot. So instead of 90 counterclockwise, let's say I go 270 clockwise. So I'd go 90, 180, and 270, and I'd end up in the exact same spot. So when we have rules for rotating 270, all we say here is this, is we say same as rotating 90 degrees. It's the same rule, you're switching the X and Y coordinates and changing the signs on one of them, and it just depends on the direction that you're going. Because like I said, rotating 270 clockwise and rotating 90 counterclockwise is the exact same thing. All right, so with all that being said, let's get to this last example here, and then we'll be done for today. Okay, let's look at this here. Move myself over one more time. Yeah, that's fine. Okay, so it says, given these coordinates for the triangle, so notice now we're not given a drawing, we just are given the coordinates. I want to be able to use these rules to show where's the shape going to end up when I rotate it 270 degrees clockwise. So first thing I want you to do is I just want you to copy down the points that we're starting with J, K, L. So we have 1, 3, 2, 7, and then 5, -1. If we're going to find out where these end up, we have our new coordinates. So we have J prime, K prime, and L prime. So J prime here, if I want to find that, I can go back to my rule that we just wrote down. So rotating 270, which it says is the same as rotating 90, which tells us here the X and Y coordinates switch places and then change the sign on one of the coordinates, depending on the direction or where it ends up. So what that means here is first thing we're going to do is I'm going to switch the X and Y coordinates. So J is 1, 3. Now I switch them and it becomes 3, 1. So that's the first piece here. And then I need to change the sign on one of these. This is the rule with rotating. So if I want to do that, I want to visualize where this shape would end up, or at least where this point would end up. So if we look at J originally, 1, 3, I don't even need the exact spot. I just need to know what quadrant it's in. Is it top right, top left, or bottom right? So in this case, it's in the top right. It starts somewhere up there. If I rotate 270 degrees clockwise, I would go this direction. So I go 90 degrees, 180, and then 270, which means this ends up somewhere up here. Sorry for drawing that like a little happy face, but it ends up in the top left quadrant. So if it ends up here, the question is, what is the coordinate that would change? Would it be the X coordinate or would it be the Y coordinate here? So if we're looking in this box, notice it would be the X coordinate because the X coordinates are negative over here. So right here, this is going to be negative. And now this helps us because now my rule is going to be the same for the rest of my points. I'm going to switch the coordinates, switch X and Y, and then I'm going to change the sign on the X coordinate, just like we did with the first one. So with k being 2 comma 7, I switch this to be 7 comma 2. And then which one do I need to change? Same thing as before. I'm changing the sign on the x coordinate here. And then same thing with L prime, I switch them. So 5 negative 1 becomes negative 1 comma 5. And then which sign do I need to change? Same thing as before, we change the x coordinate. So since it's negative 1, I could just erase this, and now it is positive 1. And this would be my final answer here. Okay? So like I said, this one's the toughest one because you have to be able to visualize where is this going to end up? Where am I going to see where these points are going to end? Is it going to be where the x is positive or where the x is negative? And same thing with the rest. Okay, so that is it for today. If you have any questions, feel free to let me know.